When working with Python to build web-accessible tools, the central idea is communication between a client and a server through an API. A client sends an HTTP request to a server using HTTP, often targeting a specific URL that includes a base URL and an API endpoint. That endpoint represents a resource, and the request may include a header, query parameter, or a body containing data. The server processes the request and returns an HTTP response, which includes a status code and often a JSON payload. This exchange is stateless, meaning each request contains all necessary information, and it follows patterns such as REST, where standard HTTP methods like GET, POST, PUT, and DELETE correspond to CRUD operations. In more advanced systems, alternatives like GraphQL or SOAP may be used, and authentication mechanisms such as an API key or OAuth help secure access. Rate limiting and timeouts control how frequently a client can make requests and how long it waits for a response, while sessions may persist certain data across multiple interactions. In Python, tools such as the requests library or URLib allow a client to interact with a web API by constructing HTTP requests and receiving response objects. These response objects contain the return data, headers, and status codes, and the data is often handled through JSON parsing using the JSON module. This process involves serialization when sending Python data structures and converting them into JSON, and deserialization when interpreting JSON received from a server. Whether interacting with a cloud API or a local API, the same fundamental structure applies, and the developer works within a virtual environment to manage dependencies cleanly. Flask enters this picture by allowing the developer to move from being only a client to also becoming the server. A Flask application acts as the server that listens for incoming HTTP requests and produces HTTP responses. The application, often referred to as the Flask app, runs on a development server during testing, with debug mode enabled to provide detailed feedback and automatic reloading. When deployed more formally, the app becomes a WSGI-compatible application and is served by a production server such as Gunicorn, which handles threading and multiple incoming requests more robustly. Within a Flask application, routing is the mechanism that connects a URL to a specific view function. This connection is established using a decorator, which associates a route with a function that processes the incoming request object and returns a response. That response may be simple text, JSON, or a rendered template. Templates are created using the Jinjia template engine, which allows dynamic content to be inserted into HTML while keeping presentation separate from logic. Static files such as CSS and JavaScript support the user interface, while URL parameters allow dynamic values to be passed directly through the URL and used within view functions. As applications grow more complex, structure becomes important. Blueprints help organize routes and logic into modular sections, while configuration settings and environment variables control behaviors such as database connections, secret keys, and debug options. Sessions allow user-specific data to persist across multiple requests, and middleware can operate between the request and response cycle to add functionalities such as logging or authentication. Flask extensions expand the capabilities of the micro-framework, adding features that are not included by default. For example, Flask's Alchemy integrates SQL Alchemy as an ORM, allowing models to represent database tables and enabling interaction with a database through Python objects. Flask Login manages authentication and user sessions, and Flask WTF simplifies form handling and validation. Underneath Flask, WorkSU provides the low-level tools for handling HTTP requests and responses, while the concept of context, including both application and request context, ensures that the correct data is available at the right time during the life cycle of a request. The entire system fits within a broader idea of a web API, where a Flask-based REST API can expose endpoints that return JSON data instead of HTML, allowing other clients to interact programmatically. In this way, all of these concepts form a continuous chain. A client, possibly written in Python using requests, sends an HTTP request to a URL that maps to a route in a Flask application. The Flask app, acting as a server within a WSGI framework, uses routing and decorators to direct the request to a view function. That function may interact with a database through models and an ORM, process data, and return a response, often in JSON format. The response travels back over HTTP to the client, completing the cycle. Through this interconnected system, simple Python scripts evolve into fully accessible web applications and APIs.